Hey, happy Monday, everybody. How's it going?
Happy Monday, Joe. You're not snowed in up on the hill there.
I am actually. I spent the last hour on digging, so it's a lot of fun. Welcome back to Salt Lake, though. I haven't seen you. It's like a on vacation here or something now. So
Yeah, basically.
I think you're you're
Yeah,
uh, you're you're a spring home in Salt Lake.
that's
So
right. It's not spring yet, apparently. This weather
no,
is
we're getting
crazy.
like snowmageddon right now. I think the mountains are supposed to get 50 inches of snow. So
Eek.
which what's that?
Said eek.
Yeah.
Yeah, yeah, and this is on top of like very basically weekly snowstorms here. So it's I mean, definitely thankful for whatever we get here, but yeah, it's been kind of gnarly. Anyway, good to see everybody. Larry, great to see you.
Thanks for joining.
Great to see you both.
Long time listener, first time caller. So uh,
Exactly.
that's awesome, man. Yeah, for people who don't know who you are, do you want to give a quick intro?
Yes, I've been working in IT and business for about 40 years. I used to teach business school, and I've taught in the data resource management program at the University of Washington. I've been a longtime software developer. Uh, got into the data side of things in the late 90s, early 2000s. Uh, for about 20 years, I've been the data and BI architect and kind of lead data point person for a global Fortune 200 manufacturing company. And I just retired from my day job last year to take care of a disabled spouse, but I'm still trying to keep active in the profession, and you can catch a lot of my posts on LinkedIn, and I am still writing a lot of articles and forums like tdan.com, and I've got a series of articles out now on Data Management U, the EW
Mm,
Solutions website.
that's
And I've
cool.
written 3 books on data management and BI and database development.
Got one of them right here. Good book.
Oh,
Great book, actually. It's one of my favorite books I've read in a long time, and at least in data. So it's really really good. So
well,
yeah,
thank you.
yeah.
Appreciate that. And I've been enjoying your guys' book on data engineering.
Thank you.
Thank you. Appreciate that. We didn't
Yeah.
go real deep on data modeling just because there wasn't space, which is why Joe is writing a follow up, but building on things you've done in your books. So,
Well, that's
Yeah.
great.
yeah.
Yeah, I feel that data modeling has the potential to add a lot of value to data engineering and also to help increase the value that data engineering can contribute to organizations.
Walk us through that. What does that mean? And I mean, can we back up and also define, for the purpose of the conversation, when we say data modeling, what do we mean by data modeling?
Ah,
Yes.
that's a good question too. Everybody has a different definition of things. In my books, I distinguish between logical data modeling and physical data modeling. So logical data modeling is just bringing people together to understand the business domain and the data aspects of the business domain, that in the domain in which the activity or the work is being done, and understanding what the business calls data, what the data names are, what the data definitions are, and especially what the business rules are around the data, and getting everybody on the same page about that, as opposed to physical data modeling or physical data design, which is just designing physical data structures. And so most of my writing concerns itself with logical data modeling and the value that logical data modeling can contribute to projects and endeavors in the organization.
Got it. And I guess the question I have is, where does conceptual data modeling fit into this? Because there's like, for the audience, there's historically, when you look through traditional data modeling, it's like conceptual, logical, and then physical modeling. It's yeah.
Yeah,
Where does conceptual fit in with you?
Conceptual data modeling, to me, is like a logical data model in a much more simplified form.
Got it. Okay.
It shows very few of the attributes, except for maybe key attributes, and mostly shows relationships between data entities. And it's designed to foster conversations at a high level of the business, maybe with business executives, high-level managers. Whereas logical data modeling, to me, brings together like the lower level business analysts, business users, product managers, application developers, and brings those people together to understand the business data domain that they're all going to be working in. And a physical data model is mostly targeted at application developers and database developers, the people who are going to be, putting all the nuts and bolts together.
So the logical model is like a much more precise version of the conceptual model. Is it fair to say that? Where with the conceptual model, you define maybe business terms. With the logical model, you're very precise about exactly how different metrics are collected, for example?
It's one of the most important differences is in the logical data model, you're capturing a lot of business rules that constrain the values of data, and you want to make sure to understand those rules. If you want to throw up the timesheet illustration real quick, I can kind of walk you through how this works.
Yeah, let me share my
This is
screen here real quick.
This is from an actual project I worked on where I was sent to a division to save a project that was 8 days away from a non-negotiable drop-dead delivery date, and they were testing. It was user application testing and QA testing, and every time the testers tried to use the application blew up, and nobody could figure out why. And so they sent me to this division to try and save the project and deliver it on time. And they, as I said, they weren't sure why the application was blowing up. They thought it might have something to do with the database. So I said, show me the database. And the database was basically this one table called tasks. And the key was task ID, which was just a random sequential number. And then you have all of these fields in it, like employee name and number, project name and number, task name and ID, week number, a bunch of buckets for hours. And the first thing you notice is that the thing is called tasks, but it's not task data, right? You can kind of look at this and guess what kind of data it is.
Yeah.
It's timesheet data or time card data. This was a time card entry system. But the table's called tasks. So the first question you ask is, why are we calling it tasks if it's timesheet data? And you may say, well, it's just a database table. Who cares? You can call it X or foobar. But the point is that unless you name things the right way, you can't have intelligent conversations about them. So once you rename this as timesheet or time card, now you can ask some intelligent questions like, from the business point of view, what is a time card? Well, looking at this, it looks like a time card is the record of hours worked by an employee on a task for a project in a given week, right? Which means that employee, project, task, and week are key attributes. They're attributes whose values are set at the time the time card is created, and then they never change after that. But if you look at this database structure, all of the fields in this table are nullable. So you can create a time card with absolutely no data in it. You can create a time card that has no employee information on it or no project, or a completely invalid employee, somebody who doesn't even work for the company, or a task that's not a task in a project, or an invalid week. You can create a time card for one employee and then change the employee name afterward, or change the week. You can do all kinds of crazy things. But the point is, that's not the business's, that's not the way the business sees a time card. Those aren't the business rules around time cards. So this database structure allows data to be persisted in a way that violates the business's understanding of what a time card is and how a time card works. And this is part of what was causing all the problems with the application.
That's interesting. I mean, this reminds me, Joe, of that client you were working with a long time ago where they had this ancient IBM DB2 database running, and the field names were very constrained. The field names could be like 8 characters long. And so basically the field names told you nothing about what data was actually there.
Well, there was no documentation.
No documentation.
If you ask the sole developer, he would say, I don't know what that means, and walk away. It's really helpful.
And that's another way that data modeling can help add value to the data engineering process. I mean, I've worked for companies where their idea of data engineering was just, let's grab all the tables from all the on-prem databases and just dump them up in the cloud somewhere in some kind of repository. And then we'll give the business users copies of Tableau or something, or Power BI, whatever, and point them to this big morass of data out there and say, okay, you're on your own. But a good data model can help business users understand what all this data is and how all this data fits together, and allow them to consume this data more quickly and more accurately, get value out of it faster. And a good data model can also be used by data engineers to construct view layers on top of data in data lakes or whatever. So instead of having all of these blobs of data with 8-character data names, you can construct views over that have business sensible data names, and where the various tables are joined together in a reasonable way. And those views will enable business users to be able to consume that data more quickly and more easily. And that's how data modeling can add value to data engineering, and how data engineering in turn can add value to the business.
Yeah, that's absolutely right. It feels like data modeling really should be more of a full contact sport, between business and, I guess the data people. Right now, it feels like, I'd love your take on this too, because right now it feels like any data modeling exercise, if it even happens right now, I think before the show, I also made a comment that it feels like in some circles, data modeling is basically on life support right now. And so, which we can talk about too. But it feels like in a lot of cases, the role of a data professional is really, if they're tasked with modeling, is to basically go and sort of be a phrenologist in some ways of the business. Sort of feel around a bit and like interpret what's going on and come up with what they sense is what the business intends with this data, without just going ahead and maybe asking people how does this business work.
It's one of my pet peeves. For example, in my book, I have a section there on domain-driven development. And so I read all the books on domain-driven development, Eric Evans and everybody. And those books are always written completely from an application developer perspective. Most of the time, they don't even mention anything having to do with data, and especially not anything having to do with data modeling. But in Eric Evans' book, he consigns everything having to do with data to what he calls the infrastructure layer of the project. And this is totally wrong. data models and everything having to do with data architecture, data design needs to be in the domain layer of the project for three reasons. One is that the data model helps define and helps everybody understand the business domain, because data names, definitions, data business rules are a part of the definition of the business domain that everybody needs to understand in order to do their work successfully. Second, as Eric Evans himself says, the domain layer is where all of the models reside, including the data model. And also, according to Eric Evans, the domain layer is where all of the business rules reside, and the data model captures the data business rules. So the domain layer is the most important layer of domain-driven development, and the data model and the associated data architectures and so on need to be part of that domain layer.
Yeah, I completely agree. And I think what happens too often is that maybe the application development teams work with that domain model, but then the analytics side is treated as completely downstream and separate, and there's no communication between the two. And so the data side, like the analytics side, is just handed all this data and told, do something with this. The business might care about this stuff, but we're not going to tell you what it means.
Yeah, and there have been some attempts, I would say, like data mesh is an attempt, I think, to bring
Yeah.
domain-driven design to data principles, basically. But I think, as you point out in one of the articles, I think it was on TDAN or something. It was article number 4, domain-driven development and data mesh. Well, I think before I mention that part, what goes wrong with domains when it comes to data? I think there's a punchline here.
Yeah, and what goes wrong is that data needs to be defined consistently across all the domains in which that data is used, and a lot of times it isn't. If you want to throw up that bounded context model that I sent you,
Is it the one that's like streaming data illustration?
No, it's bounded context, I think it's called. Let's see.
If you sent that, I do not see it.
Oh, you're kidding.
Oh, sorry, technical difficulties here.
Oh. That's all right. Anyway, the point is that in this illustration from Martin Fowler, there are two business domains, sales and service, and each domain has an entity called customer, and each domain has an entity called product. But the question is, are these the same things or different things? It's possible that the customer who buys a product may be the same customer who has the product serviced under warranty, or maybe not. It could be a different customer of the same kind, or it could be a completely different customer. Like I work in the trucking industry, so a truck driver, an owner operator, may sell a truck to another owner operator, and some of the warranties may still be valid. Or a fleet dealer may sell some old trucks to an owner operator, in which case the customer being serviced is a different type of customer. But see, these are the kind of questions that have to be asked, and which aren't going to be asked unless you're doing data modeling. But now product, if you look at product in a sales context versus product in a service context, those are obviously two different things. If I order, say, a printer from Amazon, I'm not ordering a specific printer. I'm ordering a particular make and model of printer, and they grab the first one of those they have on the shelf and they send it to me. So product in a sales context is actually product model, which in most companies is a master data entity. It shouldn't be defined and persisted at a domain level or a subdomain level. It needs to be defined and persisted at a much higher level of the organization, maybe in a master data management catalog. So these are the kind of questions that a good data modeler asks, and it surfaces a lot of information that helps to define what data entities and attributes are domain specific or subdomain specific, or which data entities and attributes span business domains or subdomains. Like the last big project I worked on was a warranty application. So you have some warranty related attributes, entities and attributes that are part of the warranty domain, but then you have other entities and attributes like dealer or product master that have to be defined at a much higher level. You don't want every business domain or subdomain to have its own product master list. That wouldn't make any sense. So that's part of what a data model does, is helps define at what level of the organization a particular data entity or attribute should be defined and persisted.
Well, you mentioned master data management just now as like a really critical thing, and I've been thinking about master data management since we've been on this discussion because it was kind of implicit in a lot of the things that we were discussing. How pervasive are good MDM practices right now? In other words, if you were to look at Fortune 500 companies, what percentage of those maybe have a good master data management practice from your perspective?
I couldn't begin to tell you. I think that some smaller companies do a better job with MDM, like Costco, Starbucks. They have really good MDM organizations. They have teams of 25, 30 people that just do MDM. Whereas the Fortune 200 company I worked for is just barely now starting to get its toes wet in MDM.
Well, it seems like it might be a bigger challenge at a bigger company because you have more products, you have more people, you have more divisions, maybe you have smaller companies inside of the big company. What are your thoughts if you were to talk to a CEO at, say, a Fortune 200 company? How would you suggest that they start this process? Like, how do they get MDM going in their organization?
Yeah, I would start with product master. I really, a lot of people say, oh, let's start with customer, but customer MDM is horrendously complicated and time consuming and expensive. Whereas product master is a lot easier to wrap your head around and to get some kind of handle on. So that's where I would start.
That's really interesting. We kind of bring it back to data modeling. What are some of the challenges you've seen with data modeling, especially as it relates to data engineering?
Yeah, I think to me the thing that I would like everybody to understand is that one of the principal values of data modeling is to bring people together to understand the business data domain and the business data rules. A lot of people think of data modeling in terms of let's just design some database schemas.
Mm-hmm.
And that's not really where the value of data modeling is. There is some of that. A good data modeling tool, you can create the logical data model, and then you can do the physical data design in the same model and press a button and generate a database schema. Or if you make a change to the data model, you can press a button and generate a Delta script. And that's great. That's a part of model-driven development, because an MDD model not only brings people together to understand a problem and agree on a solution, but the model is also used to generate part of that solution.
Sorry. What's MDD?
Model-driven development.
Right. Okay.
So one of my mantras is that a logical data model needs to be both an MDD model and an Agile model.
Mm.
So, but it's very important to understand that even if you're not creating a relational database, for example, even if you're doing NoSQL, even if you're not doing a database at all, on any given project, people have to understand the data that they're working with, and they have to understand it from a business point of view. And that's where a logical data model helps develop everybody's understanding and bring people into agreement on how data is named, how it's defined, what business rules constrain it, the domain or domains in which that data entity is valid. Is data needs to be named consistently and defined consistently across all the domains in which it's used. One of the things that I said in that series of TDAN articles is that if you have the same data entities and attributes and they're defined differently and named differently in different domains, then every service, every application that uses that data has to do a data translation. And that becomes incredibly expensive, and it impacts the performance and scalability of applications.
Well, I mean, I think we've seen this over and over again, just what you're talking about, like just lack of communication between software teams, lack of consistent data, lack of consistent metrics, and a lot of it does fundamentally come down to a leadership and communication problem and not a technical issue.
No, I mean, modeling isn't a technical thing, right? It's a communication and context understanding, and it's and what's interesting too. Sorry, I'm about to lose my voice here. The recent, I would say, crop of analytics engineers, especially, they're using a lot of DBT, which is a wonderful tool for data transformations. It's phenomenal, but DBT calls some of their files models. And what I'm noticing is people are who don't have the context of data modeling are now thinking that these DBT models are in fact data models. So they're data modeling, but they're doing it within the context of a DBT tool. But because they don't have the context, they're sort of mixing and matching terms, so to
right.
speak. So
they're basically doing physical schema design.
Yyep, exactly.
Which is sometimes not even that. Yeah, and sometimes not that. Really just a couple of SQL queries to transform something, which is great, but there isn't even really a defined schema. It's just kind of like take the data. It
more like an ad hoc query.
Ad hoc queries that are dump some data in a table. I mean, what you were saying earlier, Larry, about you see companies grabbing all the data in source tables and just dumping it into a target database. That's very, very familiar. And I think what's happened is the tools have almost made things too easy, right? So a decade ago, you would have signed a big contract with Teradata, Oracle, something like this. It was so much money that you were probably going to train your team and make sure they knew what they were doing. And now you can kind of drop in a Snowflake, which is an awesome tool, but it's so easy that people don't really get any training on how to use it or how to transform data or how to model it.
Yeah, it is interesting too, because I think there's almost, it's like everything in the world now. There's almost everything's too easy and there's too much information, and so and the thing is too, with certain technologies, I would say that there are Slack communities, for example, where people can trade tips, but it becomes sort of a self-reinforcing echo chamber in some ways, where if you want to follow the practices of the tribe and that Slack community say that's kind of how they'll do it, right? And so, but what it means is like everything else in the world now, you sort of lose the perspective of reading books, for example, or reading more widely to gain context. So it's an interesting time.
Developing expertise. I mean, technology technology gives us the ability to do lots of things that we don't understand anything about, and so it
Yes.
enables us to shoot ourselves in the foot more easily. But there's really no substitute for expertise. There's a great story about a company in Japan that wanted to make a bread maker, and so they built this machine to make bread, and the bread was coming out all doughy and plasticky and elastic, and it was just terrible. So they took one of their engineers, a woman, and they sent her to the best hotel in Tokyo, where she worked for something like a year or a year and a half in the bakery, baking bread and cakes and rolls and pastries and things. And then after a year and a half, she went back to the company and told them how to design the bread making machine. But that's, so it's not just the technology, it's having the understanding of what's going on that enables you to use the technology intelligently.
It's such a understated, I would say, practice also to develop expertise. I would say it's also something of a lost art in some ways. It's interesting. I feel just what I've noticed, back in the day, before the internet, you'd have to read books and articles, and there wasn't as much information, right? So, like, to read a book like this is just sort of what you would do. To read a book like ours is, well, people read your book, people read our book, but I think the point is it's a lot easier to, I guess, sort of, do things first and then figure it out later. So,
Well, it looks easier. It seems easier at the time, just like the bread machine that didn't actually bake bread.
yeah, exactly.
Mm-hmm.
So, actually, Mark Keeling has a really good question here. He asked what resources are recommended to learn proper data modeling techniques.
Well, certainly I'll recommend my book.
Yeah.
And of course, anything by Steve Hoberman, Donna Burbank, Graham Simpson has some great books.
John Giles.
David Hayes, John Giles, yes,
Giles, yep.
my good friend, colleague from Australia. Yeah, there's a lot of good books on data modeling, where I feel that my book adds some particular value is that it talks not just about how to do data modeling, but ways in which to use data models as storytelling tools, as ways to bring people together and fuel discussions that need to occur and come to agreements and document those agreements and just get everybody on the same page. You remember that timesheet example, that time card example?
Yeah.
And I said that the application was blowing up every time somebody tried to use it. Did you ever think about why the application was blowing up?
No, I want to know the rest of the story. I was thinking.
Yeah, I
about
actually
that.
want to know that too.
What happened?
Because they said, oh, it's blowing up in the database, but the database lets you do anything or nothing with the data. The database isn't enforcing any data rules. So that's not where things were going wrong. They were going wrong in the application. And the reason was that you had like 3 groups of people who were not on the same page about what the data was. The application developers were doing what application developers do. When you write code, you sort of either consciously or subconsciously embed in the code your assumptions about how the thing is supposed to work. And so the developers understood kind of how time cards were supposed to work, and those assumptions got embedded in the code. Meanwhile, the people who built the database weren't enforcing any of the business rules about this data. They were allowing the data to be persisted in ways that violated the business's understanding of the data. And then you had your QA testers who were doing what testers always do, testing out edge cases. What happens if I change the name on a time card after the time card's been created? What happens if I change the week, or if I create a time card with week 99 in it, or an employee that doesn't exist? And so the testers were doing things with the application that the database allowed, but the application didn't, and that's why it was blowing up. But the point is, you had three groups of people on a project who didn't have a common understanding of the data and the data rules. And a data model would have brought all those people together, given them a common understanding, and then everybody would have been on the same page, and you wouldn't have had these problems.
So how do you? Go on, Matt.
Oh, I was going to ask, like, so it sounds like we're talking about exchanging specifications, so specifying what the data is. Both you got your conceptual, logical, technical models, and everyone needs to understand what those are. So how do we create specifications like that, but still maintain agility?
Yeah, well, part of it is that, in a data model, you can capture all of this understanding and all of these agreements, and then you can put that data out in a number of different forms. You can create an ERD and send it out to everybody. The version of the data modeling tool that I use interfaces with Crystal Reports, so I can create reports almost instantly in Word and send them out, or I can also download all of the metadata from the model in Excel and send that out. And usually I do all three, and I create the Word documents, the Excel spreadsheet, and the ERD PDFs, and I post them up to the project SharePoint, whatever, or Teams, or whatever the project is using, so that everybody has this information to use. I know that I've done a good job as a data modeler if I go into meetings like design meetings or requirements analysis meetings, and everybody's carrying a copy, a printout of the data model, and they're referring to it while conversations are going on.
That's a good call.
And then presumably if it's agile, it's like if there's something they don't like, they're like, hey, this makes no sense. They'll cross it out and give it back to you, and let's figure out how to update this together.
Right. Again, every logical model has to be an agile model, which means that the model is owned by the team and it's developed incrementally, and everybody has a say in what the model ends up looking like.
Mm-hmm. Interesting. Walk us through that process. If you're say if there is no data model explicitly, I also argue that no data model is also a data model. It's just really crappy one. Yeah, say you're tasked with leading the data modeling initiative at your company. What are the first things you do?
Well, usually on a project, there's several week period where all of the interested parties, the business stakeholders, the sponsors, the product owner, everybody gets together and starts talking through how the application is supposed to work, what it's supposed to do. They start developing the user stories or the use cases, building the backlog. And while all of that's happening, I can be sitting there taking part in the conversations, eliciting what the important business data entities and attributes are, and kind of modeling as I'm going along, participating in these conversations, so that when the project actually starts, I have a sort of a straw horse data model that covers at least the majority of the use cases. Maybe at a high level, maybe we haven't drilled down into a lot of specific attributes that will be needed for individual user stories. But at a higher level, I've got something that everybody can look at and start talking through. And then, for each sprint, if you're doing Scrum or whatever, there's at the start of each sprint, you're selecting stories from the backlog to work on, you're discussing them, you're sizing them. And while that's all going on, I can be updating the data model to reflect the conversations that are going on, the understanding that's being developed. And that process of refining the data model goes on through the sprint as we're doing user story analysis and user story design. It's just the data model becomes part of the driver for the conversations that need to happen, and it becomes part of the documentation of the agreements where everybody has agreed on what the data is supposed to look like. And then, as I say, I also have the ability through the data model to generate part of the database schema or all of the database schema and put that out there. I can generate DDL for a database, put it out on GitHub or whatever repository everybody's using. And then the developers can grab that, put it in their process flow. When they're generating new versions of the application, they can generate a new version of the database, they can run their smoke tests, and they can do their deployment. So it's sort of like that.
Interesting. Actually, Ryan Dolly has a point here. I'm sorry if my voice sounds weird. It's because I lost it for the last several days, so I'm just now getting it back. So
you got pretty sick, Joe. So
yeah,
good to see you here. With
thank you. I wasn't sure I was going to make it.
Yeah.
So Ryan asks, he feels like Larry, you're talking about the classic data architect role here. Do organizations still have that role? He feels like it went a bit out of style, or is this more of kind of a team thing now?
Yeah, I mean, the organization I worked for had the data architect role. I was the data architect. But I think in a lot of organizations, maybe the work of the data architect now is part of the data engineering role. And so even though I was the data architect for our company, I was still very much involved in day-to-day project work, data modeling, database design, database development, SQL coding. I worked on project teams quite a lot. So it may be that I still think the data architect role is valuable at a higher level. One of the things that I did was I worked on what was called digital strategy, which was basically the monetization of data or the application of data to high value business initiatives, customer centric initiatives. But I think a lot of the nuts and bolts stuff that I did as a data architect now becomes part of the data engineering role and data engineering teams. And so the skills that I have that I used on projects are skills that data engineers need to have now.
Right.
Yeah, and we kind of talk about that in our book, how a lot of things that used to be under architecture have been handed to data engineers to some extent in many organizations. And I think this is still being actively debated. I mean, it's a contentious topic.
Well, which part?
Just that whether data engineers should be doing these things or not, whether you should have architects or not.
I think it just depends.
It depends, yeah.
I think a lot of organizations don't understand data engineering now. I mean, it's something that's been around really for as long as I've been working in IT, but now it's starting to be defined a little more specifically. But I think organizations still don't understand data engineering. A lot of organizations think of data engineering as just building pipelines to move data from point A to point B. And I think data engineering needs to be much more valuable than that.
Oh, for sure. Yeah, I think on LinkedIn the other day I saw somebody say, "Oh, data engineering is 99% software engineering," and I was like, "That's absolute. That's maybe one aspect of it, but your job isn't to build pipelines. If that's all it is, then to us it's lifecycle management, right? So, among other things here, but yeah, but again, terms shift and definitions as we've been talking about for the last bit. They're constantly evolving, and it's hard to get people to agree on these things. And so,
Right. It's like people defining data modeling as nothing more than schema design and schema development. We need to find ways of being much more valuable than that. I think organizations and other people tend to put people in boxes.
Mm-hmm.
And they put data people in boxes, and they put data modelers in boxes, and they put data engineers in boxes. And I've always felt like we need to break out of the boxes and find as many ways as possible to contribute the most value that we can for our organizations. That's what keeps us from being, replaced by Chat GPT or whatever.
Right.
When
That's
we
so
can
true.
do things to create value in our organizations that technology by itself can't do.
Yep. Yeah, that was my rant last week on LinkedIn, was just basically how, it's not a new argument by any means. I mean, I've heard the same thing for decades, but it's like it's the argument that we need to stop leading discussions with data. Learn to speak the language of your stakeholders. Get out there and understand the problems they're trying to solve and help them solve it, whether or not you're using data or not. It's kind of immaterial to me. Hopefully, you're using data, but if you don't know the problem you're solving, then how do you know how to solve it? Right. So that's the whole crux of it. I just feel like as an industry, we're going absolutely backwards with everything, or in reverse, I would say. We're leading with data. As you point out, organizations don't understand data engineering, I think largely organizations don't understand data either still.
It's always been a problem with IT from time immemorial. IT is always led with technology without understanding what the business actually needs to do in order to make money or be successful.
Mm-hmm.
But we have cool technology.
Yeah, really cool technology now. So
it keeps getting cooler, but we still have the same problems.
Right? Yeah, and I think. Yeah, what are your thoughts on ChatGPT? I know you've been writing a bit about this.
Yeah, I have a tdan.com article out on ChatGPT, and part of what I feel about it is that it's going to kind of enforce mediocrity. That ChatGPT is a very easy, convenient way of doing what everybody else is doing or would do if they were able to do it. So, it draws from what people have put out on the internet. And so you're going to get from ChatGPT just kind of the least common denominator of what everybody else is thinking and what everybody else is doing and what everybody else has done. And it's not going to be anything more than that. One of the examples that I give, people say, oh, people will never have to write SQL code anymore. ChatGPT will write all the SQL code for everybody. But the example I give is that ChatGPT would know, for example, if you wanted to filter a query against a delimited list of values, it would put it in an in clause, right? Which is the one thing that you don't want to do because it's horribly non-performant. What you want to do with a delimited list of values is to translate it into a single column table using a table valued function and then join that table to the query. That's much more efficient. But an AI bot wouldn't know to do that.
Yeah. And who knows, it might at some point, right? But it's like, I think the domain expertise is the one thing where it's still, maybe it'll be trained on your own data, right? But I think that just means too that your ability to have, I think it's going to force engineers, for example, to, I think, be more cognizant of the business, because all the rote tasks will, if you kind of take it to the logical extreme and all programming is basically automated at that point, what are you to do? I would think that, being able to add value, as we talked about, is probably the mandate. So as it always has been.
They talk about all the jobs that ChatGPT will eliminate, but AI is only going to eliminate the jobs that can be done by merely following a set of instructions.
Mm-hmm.
which unfortunately a lot of jobs are now. You get a
Yeah.
job and your boss gives you a list of instructions to follow and steps to follow. And if you do anything outside of that or show any initiative or creativity or whatever, you get slapped down for it. But those are the jobs that AI is going to eliminate, the non-value added jobs, so to speak. And so if we want to keep our jobs, then we need to find ways of adding value to our organizations that automation can't. That's basically the bottom line.
Yep. Yeah, I know. I've been telling my kids, go find a career path that's not going to be automated. They're 10 and 12, but it's an interesting thought experiment too. Because I'm like, think about what could a machine do today and tomorrow. What are you good at, and what So what's that set difference of the two? So
yeah, and basically anything that involves working with people, bringing people together, helping people become successful, helping people achieve what they want to achieve. Those are the kind of jobs that aren't going to be automated away.
Yeah. Or handiwork, right?
Yeah, you've joked about that, Joe, right? Like your kids should go into like plumbing or construction.
Oh, I'm not joking about that. I think that they really should actually. It's a good. It's an awesome career. You know how much money my plumber makes? More than we do.
Yeah. Seriously.
Yeah. I mean, yeah. So, and I think just, yeah. It's going to be really interesting to see what happens. I mean, I think this is, generative AI in general is one of the big, it reminds me a lot of when the web browser came out. All of a sudden, it's like just, I remember that day, Mosaic was launched, and it's like, okay, this feels like this is I was beta testing it before it came out, but it just felt like the reception to it was one of these things where I was like, okay, this is going to be a different thing. So, and I was just a kid at the time, but this feels a lot like that, where you can tell this isn't just a fluke, this isn't just a fad. So,
right, but what technology ultimately becomes is really up to each of us. It's like social media could have been a wonderfully constructive, creative, uplifting sort of technology. Now a lot of social media is extremely toxic. You've got little groups of trolls attacking everybody else, and all kinds of animosity. So technology itself is really neither good nor bad. What technology becomes is what we decide to use it for.
Yeah, exactly. Matt, you look like you want to say something.
Oh, just like the trolls attacking people. That reminds me of a lot of data modeling discussions these days.
Oh, geez, that's for the next episode.
Right.
Well, even on LinkedIn, you see it.
Yeah.
You see a lot of people attacking other people.
Yeah.
Oh yeah.
Yeah.
Well, it reminds me of what is it, Sayre's law, which is the one, Matt, that you talk about a lot in academia, which is the fights are so vicious because the stakes are so small.
Yeah. Well, because think about it. Let's back up a second. Just like you were saying, Larry, the technical model is almost the least important piece. Like it is really important, but it needs to be subservient to the other layers. And yet we spend so much time arguing about that technical model and not about the logical models and semantic models, basically.
Right.
Yeah. I mean, there's certain people I won't name, but and I feel like it does. There are people that I think viciously attack other people, in data modeling discussions, and I really feel like it might satisfy their ego. I think in the larger discussion, it does a disservice to data modeling in general. I mean, like we said earlier, I mean, my personal impression is I feel like data modeling it's on a form of life support at this point. I mean, I think people like you, Larry, are doing a great job at, I think, being a calming voice of reason and telling people why it's important. That's people like Serge from SQL DBM. He's writing his book on data modeling, and I'm writing mine, and there are others, of course, and there's obviously a lot of sane people, which you mentioned earlier. But for every one of those, it feels like there's a lot of just a lot of gatekeeping. It feels like, and if you're not doing things in normal forms, or if you're not using this approach or the other, then you're basically human garbage. And that's sort of the vibe I get from a lot of these discussions. And I think it's holding the industry back. Like, I think more than ever we need to come together and advocate for data modeling as a great practice, because it is, right. I mean,
It really is. I think that it may be true that in a lot of organizations, data modeling is no longer going to be a separate role, perhaps. I think it should be, but in a lot of organizations, I think it may be that the data modeling role becomes subsumed as part of the data engineering role. And data modeling will become a skill that data engineers will need to have in order
Yep.
to do their jobs in the most effective way possible.
Completely agree. I mean, so what, I mean, what do you think? What do you think is next in data modeling?
There's a lot of new modeling techniques coming out that are starting to be developed. I'm starting to explore some of the new things. There's the oh, now I'm blanking on it. It's like a universal data model or something. But there are different groups of people who are trying to reinvent what data modeling is, and I'm starting to try and wrap my head around some of the work, some of the new work that's being done. I don't really have a clear grasp on it yet, but there are people out there trying to find new and better ways of doing data modeling. And I think we'll see some new next steps coming down the road. I think Joe, maybe you and I will have some conversations about some of these new techniques for the book that you're writing.
Yeah.
And I'll look up the references and
Yeah, please
send
do.
them to you, and maybe that will be a topic for another conversation.
That'd be terrific. We'd love to have you back on. I mean, yeah, like I said, you're one of the people I deeply respect in this field, and I don't say that lightly. So, but just the way you think about problems, and express them is just it's on a much deeper level than I see most people operating at, and so it's cool to see, right?
Thank you very much. I really appreciate it.
Yeah.
I really am enjoying this conversation, and I'd be happy to come back on anytime.
Cool. That would be great. Yeah, because I do think it's time to kind of reboot data modeling. If it's been in decline, it's time to
well,
get
I mean,
back in the forefront.
Here's the things that we notice. Like Matt and I talk about this a lot. I mean, think of the number of data tools in the space right now, right? Things like observability and quality tools and so forth. And I think these are great, but I think they also are, that are kind of addressing problems that happen upstream.
Yeah.
And if you look at the problems upstream, a lot of these could be solved if you just had a better data model. So it's the old trope, like, data scientists spend 80-90% of their time getting and cleaning data and all that kind of stuff. And I'm like, I mean, if there's a way of maybe having context, of maybe having a data model that made sense, not just in one domain or, one silo like applications, but, data and software engineers work together mainly. I think that would go a long way towards, solving that problem.
Yeah, and taking some of the burden off of our business users.
Yeah.
So much of IT, IT shifts a lot of the burden of its poor processes onto business users. Yep. So we don't understand our data. We haven't modeled it correctly. We haven't persisted it correctly. We don't have adequate metadata. And so our business users have to spend 40-50% of their time trying to figure out what data they need, where they can get the data from. They're trying to understand it. They're trying to cleanse it. They're trying to integrate bits and pieces of it together. They're working in the dark a lot of times because we're not giving them a lot of help.
Right.
And it's eating away at their productivity.
Mm-hmm.
Yeah.
And they'll start asking ChatGPT for all their answers instead of the data team.
Yep. So. There's just a lot of mutual disdain between IT and business, and that's very unfortunate. We gotta break down those walls of communication.
Yeah. It's interesting though. I mean, Bill's chimed in on a couple posts recently, and I mean, and I've talked to him about this quite often, and it feels this Bill Inman, but it feels like the tension between IT and business is just one that I don't know how this goes away, but he's seen it since day one, and day one for him that's been that's a while.
Literally day one. The point that I made in response to something Bill said was that the big rift that I see is not between business and IT, but between IT and IT. Because because you've got one big chunk of IT that's just keeping the lights on and maintaining the infrastructure, and then a much smaller part of IT that's trying to actually create value for the business. But that part of IT can't get funding, can't get management approvals, doesn't get management support, because so much of IT's budget and everything is dedicated to just keeping the lights on and the servers up and running and so on. So we really need to split IT up, between the operations part of IT that's maybe under the COO and the value producing part of IT that's maybe under the CDO organization or the CFO organization, something like that.
Yeah, it's definitely a big difference between like playing offense and defense for sure. And just, it's a big tension. Well, cool. For people who want to learn more about you, how can they do that?
Well, certainly I'm on LinkedIn, so you can follow me on LinkedIn. I have a slew of articles on tdan.com, tdan.com. That's Bob Siner's website. I've been writing for them since 2005.
Wow.
I have a series of articles just coming out now on the Data Management U website for EW Solutions. And then I have my books, Building the Agile Database, Growing Business Intelligence, and the new one, Data Model Storytelling.
Nice. Yeah, check it out here. It's a good book, and it's on the Techniques imprint too, which is Steve Hoberman's imprint. I would say pound for pound for data books, Techniques is it's a gem. It's hard to find a bad book on his label.
They've got a great stable of authors and wonderful books.
Yeah, and especially some questions that come up about data modeling and resources. I would say Techniques. I think pound for pound is probably your best bet. Just go on Techniques pub or publications, whatever it is, and
techniquespub.com.
Okay, yeah. Just browse around. I mean, they got. I think as far as data modeling goes, I think they got the foothold on the market with that. So, and Steve Hoberman himself is a data modeler, right? He's like one of the OGs actually from the 90s or 92.
Right, and he still travels around the country doing data modeling workshops and speaking at conferences.
Yeah, he's cool. Well, awesome. As far as events with Matt and I go, what is going on, Matt? Any events with you?
Let's see. We've got PyCon coming up in a couple weeks in Salt Lake City.
It starts on the 18th, I think, in Salt Lake City. That's going to be good. That same, I think the 19th or something like that, 19th. We're doing a Utah data engineering meetup with Mother Duck. So you should go check that out. And on the, what is it, the 13th, I think it is. Thursday the 13th, I'm doing a live webinar with my friends over at Matillion. We're just talking about data teams and so forth. So It's going to be a lot of fun. So support them out their new podcast and new venture. Next Monday morning data chat, we have Andreas Welch, who's a VP of artificial intelligence over at SAP, or I think in Europe they call it SAP. So they're a small startup. Just kidding.
You've heard of them.
You may have heard of SAP before. I don't know. And then I'm trying to think of any other events we have going on this week. Surprisingly, dead actually for events,
which is good because we
gives you more time to shovel snow.
Yeah,
you're gonna need it, man. It is dense. So there's a lot going on. It's a rare week. We don't have travel or too much going on. Oh, and DreCon's the 19th as well on April. It's gonna be speaking at that. So shout out to Big Eye and crew for that one. What else? Sorry, I'm just looking at my calendar this month here. Yep, that's about it. So cool. All right, Matt. Well, it's good to see you in Salt Lake, Matt. You have to pop by and let's get some lunch.
We'll grab some lunch.
Bring your snow shovel.
Yes.
Bring a snow shovel. Yeah,
Some
yeah,
boots. Yeah.
yeah. I might come visit you. Actually, I got 4-wheel drive, so
That's not a bad idea. Maybe we can meet somewhere down in the city for lunch. So
that'd be
anyway,
dope.
we'll make our
Cool.
lunch plans
Okay.
and see everyone next week.
All right. Thanks, Larry. Talk to you soon, man.
Thanks, guys.
Thanks,
Great to
audience.
talk
Great
to you
questions.
both.
Likewise. Thank you.